This is 1.3, number 1, for real numbers, chapter 1. Prove that root 5 is irrational. Irrational number is a number which is not a fraction. Okay, which is not a fraction. So let root 5 equal p by q. Okay, p and q are integers or co-primes. Okay, let p and root 5 equal p by q be a rational number, and q is not equal to 0, never equal to 0. Here p and q are co-primes. Co-primes means that p and q are divisible by 1. The factor that can divide both p and q is 1. Okay, let's say 3 and 5. 3 and 5, what is the factor? Is 1, because 3 and 5, there's no number that can divide both 3 and 5, or 3 and 7, or 13 and 17. They are co-primes because they're divisible only by 1. Okay, so squaring this 1, what we get? Root 5 square equal p by q whole thing square. So root 5 square is 5, and p square is p square is p square, q square is q square. Okay, so q square to 5 q square equal p square. Okay, this is equation number 2. Since p square is divisible by 5, p is also divisible by 5. Okay, p is also divisible by 5. Okay, let's consider p square to be, let's say if it is divisible by 5, let's say p square is 25. Okay, if p square is 25, that means p square equal 5 square, and p is 5. 5 square is divisible by 5, and 5 is also divisible by 5. That means if p square is divisible by 5, that means p is also divisible by 5. Okay, similarly, if let's say p square is 125, so 125 is divisible by 5, and 15 is also divisible by 5. Or if p square equals 625, 625 means 25 square divisible by 5, and p is 25 divisible by 5. Okay, so if p square is divisible by 5, p is also divisible by 5. Okay, so now let p equal 5k. Just take it. Let p equal 5k and put this value in here in equation 2. 5q square equal 5k whole thing square. That means 5q square equal 5 square is 25, and then k square, 25k square, which means q square equal 25k square divided by 5. 5 into 5 you get 25 equal 5k square. This is also the same. If q square is divisible by 5, that means q square is 25 or 125 or 625. Okay, so if q square is divisible by 5, then q is also divisible by 5. Okay, this q can be 15. That means q square is 15 square. 15 square, it is divisible by 5, and 15 also divisible by 5. If q is, let's say is 6 to 5, that means q square is 6 to 5 square. 6 to 5 square is divisible by 5, and 6 to 5 is also divisible by 5. Okay, thus 5 is a common factor of both p and q. That means 5 can both divide p and q. P and q are divisible by 5. But that is a contradiction. Because why? Why is that a contradiction? Because we have seen that p and q are integers or co-primes. Co-primes are just integers. And co-primes can be divisible only by 1. But here there's another factor, 5. So that is not possible. Therefore, this is a contradiction of root 5 being a rational number. Hence, root 5 is an irrational number. Okay. Suppose, okay, another thing. Suppose root 5, we know that the square of root 4, let's say root 4 equal 2, isn't it? Root 4 means 2 square. Root 2 square equal 2. But root 5 does not have a perfect square. It will have a, let's say root 5 will be 2.23 something, okay? Non-terminating square, okay? Root 5 is 2.23 non-term something, okay? To infinity whole thing square. The decimal will be non-terminating and non-repeating, okay? Non-terminating and also non-repeating. That is why this root 5 will never be a perfect fraction. Let's see here. Here, 2.23 to infinity equal 223 to infinity divided by 1, 0, 0, 0 to infinity. Never a perfect, which is not equal to a perfect fraction. That is why root 5 will never be a perfect fraction. You will never get a fraction out of root 5. Because the denominator here will never end. The numerator also will never end. It will never end from here and here, from both sides. That is why root 5 will have a non-terminating, means never end. Non-repeating means the numbers will not repeat. Okay, the numbers will not repeat here. 2, 3, 6, and then whatever numbers that will come later. It will be non-repeating. That is why it is a irrational number. Okay, if we get a non-terminating but repeating, it is a rational number. But non-terminating and non-repeating means irrational number. Okay, so that is the reason why that root 5 is an irrational number. Okay, and this we have proof that root 5 is an irrational number.